Hi, welcome to the Proteus simulation of function generator based on a PIC 18F4520 microcontroller. The main component processor, which is used for processing all the inputs and giving the outputs to the DAC. DAC creates the waveforms based on the digital input from the processor. This circuit, this circuit, op-amp U3 and its corresponding related resistors are used for the zero offset circuit, and the circuit transistors and the U8 op-amp transistors and the U8 op-amp is used for the bipolar configuration. Now going for the implementation, Proteus simulation started and the system has initialized, giving an enter now. First, the user will be asked for the sine wave and the waveform which he wants. So the corresponding waveform number can be given by the user. As of now, we are starting with the sine wave, and I'm giving enter 1. And the next is the user has the option to check um, the frequency. He can select the frequencies for out of these four. For all the waveforms, we are just giving the first waveform. All the others can be implemented, and it will be shown later on. So first, selecting the first frequency, that is giving 1. Sine wave started, frequency is this one, and we can see it in the oscilloscope. Next, if the user wants to enter a new waveform, he have to just give an enter, and he will be asked for confirmation. And here we are giving y, and at this moment we are selecting square wave and the frequency as the first value. The square wave has started generating, and to mention one point over here, in case of the square waves, we are enabling the user to change the mark space ratio using the potentiometer connected to ADC channel 0. So as of now, the mark space ratio is set as 18%. That's why we are getting this waveform. We are changing the frequency, the mark space ratio, to 50%, and we are getting a 50% mark space ratio square wave. And if we increase the mark space ratio, corresponding change is seen in the Proteus simulation. Now just changing it back. At this moment, just introducing the other potentiometer. This potentiometer is used for the amplitude control. This amplitude control is available for all the waveforms, just demonstrating in this case. So I am reducing the amplitude. I hope you can see that change now itself. I am bringing it as half. Again, it is reduced to 2.5 volt. Now reducing it further, the amplitude is changed. The amplitude is really changed, going back to the maximum value, 5 volt. Now going for the next waveform. Confirmation is given, and we are selecting the triangular waveform by giving the input as 3, and we are selecting the first frequency by giving the input as 1, and we have a triangular waveform in the Proteus simulation. Now we are giving the next waveform, that is sawtooth waveform number 4, and the frequency is number 1. Sawtooth waveform is created. The 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 sawtooth waveform is created. now we are giving the next waveform, that is I will go for the pulse, then I will come back to PWM. So pulse is given, we are entering the number 6 to get the pulse wave, and the frequency is selected as the first one itself. The pulse wave has started generating and the pulse wave is generated. Now we are going for the PWM. In PWM 5 volt, sorry, the waveform time number is 5 and the frequency is set as number 1. Now there is an option for PWM, the user have to give the duty cycle which he wants. Now I am giving 80, duty cycle is 80, the PWM wave started, frequency is 0.769 Hertz. Now let me change the duty cycle to let's say 30 duty cycle. I have selected the frequency. Trying again. Okay, and we are selecting PWM-Y. Then we are selecting first frequency and duty cycle as 30. So there is a 30 duty cycle PWM. Now coming to changing the frequencies, we are taking the square wave for demonstration of the frequency change. So the first one, the frequency is selected and the max phase ratio is the square wave is generating. I'm just changing the frequency, selecting the square wave, and I'm giving the second frequency. We have a new frequency. Now I'm selecting the third frequency, that is 20 Hertz. We have a new frequency, changing the parameters to see the waveform. Okay, now I'm giving the last frequency as input, and we have the frequency change. Just want to demonstrate the zero offset. I'm taking a sine wave of frequency. Yes, sine wave is generating. Now the zero offset, the blue wave is a zero offset output, so the offset is working. The offset functionality is like we are adding a DC component to the waveform. That is a basic understanding. And the first op-amp is a summing amplifier in inverting summing amplifier op-amp inverting configuration. And the output will be inverted waveform, so we are just giving it back to another inverted op-amp so as to get the correct waveform. Again demonstrating the zero offset. Thank you.